Good evening, everyone. Welcome, HexGen, Naz, and, well, Alan. I won't try and pronounce your username because I never can. Hey, Eston. Welcome, welcome. So I'm gonna wait for a little bit more, for a couple more people to join before I get going, but... Oh, I should also... You're fine, Eston. Welcome, Obliterist. Luna. Let's also get the crowd supply campaign up for Luna. So, if you're not already, as this is directly in line with what today's stream is all about, which is USB analysis, you should sign up for the campaign for Luna. It promises to be good. About $100. That's what they're aiming for. It gives you a fully featured analyzer and exerciser that can do things like analyze traffic between a device and a host, or it's all good, Eston. Thank you. I appreciate the effort all the same. One of the other modes you can put this in is one where basically the traffic is passed through with man in the middle. And it also has the possibility, though it's very experimental support, to be a host device as well. This thing's really cool. I currently have an open Vizsla, which is a giant board by comparison, and not nearly as full featured. This is well worth backing, and as you can see, it works with the software we're going to be improving today. So if you need to do USB analysis or look into some weirdness with a USB device, or want to change traffic on the fly, sign up for one of these. They're good. They're also very, very small, which makes them quite good for fitting on your desk. Couches and chips are good. So, without all of that said, what is ViewSB? I've actually had this question privately. ViewSB is a tool for visualizing USB traffic that's flowing using an analyzer such as OpenVisla or Luna. It is written in Python with a TUI, a GUI, and a CLI. Yeah, really, Aston. So this is the package that we're going to be poking today. Now, the inspiration for this stream actually comes from the LGTM service, which I had analyzed the code like a month or two ago. And I'd forgotten all about it, and when I went looking, I went, oh, those are some fun bugs that we got to poke. Okay, so this page is a little bit hard to look at, but if I take dark mode off, it's even worse. So, but it's useful. So you can see, for example, here, this is the ViewSB decoder's standard descriptors pi. There is a function called find specialized descriptor, which does some stuff with creating this variable subclass. And then, oops. Yes, this is actually a bug. It's not a warning, which is what it thinks it is. It is actually a bug that it has found. So we're going to go and fix some of those, and we're also going to work at Oh, hey, MB Foxen. Welcome. We're gonna work on fixing these kinds of bugs and also working on its support for debugging. Oh, hey, Lillian. Welcome. Um, yeah, work on improving its debug support because at the moment, if you present it certain data, it will just die and not tell you what's wrong with the data or anything like that, which makes it limited as a tool. So, let's go after this bug first. So I said this was in the decoder's standard descriptors. Yeah, lgtm.com is good. Line 364. So the actual fix for this is quite easy. Nope, that's not the key. It's that. So that we don't accidentally shadow this variable. This is now used properly. And then the subclasses that are pulled out from this type are then iterated over and called, and we're now happy. It now won't crash and burn in bad ways. You know, I would have to look that up. Probably, possibly. It's not especially obvious, but it's in the help section. Ah, here we go. Supported programming languages: C++, C, C#, Go in the form of Golang, Java, JavaScript, TypeScript, and Python. So no, but we could ask for said support. CodeQL could be extended reasonably trivially if you can think of classes of bugs to find and that kind of thing. But like, if I show you the projects list, for example, you can see here all the very fun things I have in LGTM, and it's a nice bird's eye view of like alerts and what's wrong with the project, and you can also get a nice alerts overview, which this is all of my projects and all of the various things that have whoopsies in them. Yeah, it could be interesting. It could be very interesting adding Rust support. This is generally used though for things where there isn't a good analysis engine already. Finding bugs and issues that are trickier to maybe. This also links into GitHub. I mean, GitHub did buy the company out, so it may be that they've been focused on GitHub integration-y stuff rather than adding new languages. So the class 2e frontend may not be properly initialized. We need to go and see how ViewSB frontend is written and see what's going on there. Also, I will quickly commit that into the repo before we continue. Fix a bug found by lgtm.com in the class specific descriptor. I can't type or spell. Descriptor, location logic. Oh, search logic. So if we look in TUI, which I happen to already have open because I have been diving this code base a little bit. TUI front end here should have an init method. It does. And we see absolutely no calls here to super. So let us see where this is and how you call super. Super init is just that. It doesn't need to take any arguments. So do super init, oops, like that. And that fixes that bug. There's another one in the Qt front end. There should be. Oh, there it is. And then there's another one in the USB proxy backend. I can't actually test that, unfortunately, but we will test the other bits in just a moment. Here it is. USB backend. And again, this is just a simple in itself. So we'll just plop that in there. So that fixes those 3 bugs. We fixed that. There's some unused import stuff, which, yes, we can also deal with. Let's first patch this little lot into the version history. That'll be some work we get into in a little bit. Fixed some init bugs in the front ends and back ends. So, TUI again. It's almost like this has been slightly neglected. It doesn't use its OS import, apparently. But if I ask this to match whole word only and match case, yeah. The only thing that's here is a missing self. Ooh. I wonder if that was something that was going to get picked up elsewhere. Easily done. And the import of widget is not used. Is it not? Oh, yeah, no, it is indeed not used. So we'll add those. Cleaned up unused imports in the GUI front end. And fixed a missing self on a class function. Okay, so let us see where we're at. Also, I now have shiny new consoles. Thank you to those who helped me setting up Zish and making it all nice and happy. So, ViewSB itself, come on, has some entertaining front and back endy stuff here. First front end thing we need to do is list front ends. Okay, so those will list, and if we do list back ends, excellent. Yeah, I'm also using my Zish and Power Level 10K with some customizations to say the least. It took me a solid 3 or so hours to set it up. Yes, another one on Zish. To a point where my bash RC execs Zish over the top of bash. So what this has just done, by me doing available front ends, available back ends, is it's just checked that all of the imports are working properly and we haven't broken anything seriously bad. Badly, rather. Bash is fine. I ain't gonna bash that. So if we look at open the Vizsla, the open Vizsla backend, we can see, okay, it's got some parameters, which we actually do need to specify here so that I can get it to look at the board I've got, which is plugged in through my Vizsla. So we do speed full, because it's a full speed device. And then we can then say we want to use the TUI, because that's the one we've just been messing with. And if I now replug the device under test, we crashed the TUI! But the TUI booted, so let's see, QT, that was another one we messed with. It inits, that's good. And that works. So, good. We fixed some bugs, and we didn't break anything horribly. Let us have a pokey. Just make sure none of these displays are broken. They are not so far. It would be nice if this decoded the data. It knows that it's a control transfer request for device descriptor setup. Yeah, again, this knows this is a control request and then doesn't decode the darn thing. So yeah, this is all looking pretty good. QVTK widget plugin. I want to see if we can quiet that as well, because that's very annoying. But okay, the USB Mon backend as well needs some help. Which I happen to have open as well. Let's do the smart way of doing that, which then doesn't need that. It's actually complaining though about this thing. I don't recall the rules with regards to this. I strongly suspect if I do super to access the parent init, it'll call through this first. Also, ViewSB backend. USB backend. I'm gonna clean some calls up here because this is spicy. So what does this say? So that is giving me this comment. Interesting. I can't chain that. That's kind of annoying. What are Python 3's rules on multiple inheritance? Of course, we're going to have to go and look at Stack Overflow. Okay, MRO. Fourth, both of these inherit from first. So fourth, second, third, first. I have a funny feeling this needs to take a dummy argument, start args, which is then passed through to whatever goes in here. So we do that in order to fix this little funsy. And then we can then pass the file name here into superinit, and this will do the right thing. Because I think what it will do is it'll do initialization of USB mon backend, then USB mon backend's supercall will do file backend, and then that supercall will do the base type once. Let's find out. So if we do USB mon file dev USB mon. Now, which hub is this hanging off of? This is hanging off port hub 5. You can hope for cheap fires, but you can't hope for them to be stocked. I'm sorry. Ooh, hello. So it looks like backend itself needs to take and do the same thing. Not that it shouldn't have already, because spicy. Apparently that is not the change to make. So that init does need to be there. What the hell to do this then? Yeah, you die because you're going and trying to do a bad thing to the parent initializer. I almost want to add an extra function to ViewSB file backend here to the ViewSB backend file backend. Get my words right. To allow it to take a file as a protected function, probably. Because this is just going to be spicy, however I slice it. Oh, it was complaining because that, okay. Let's put some star args back in. I might have just spotted my mistake. All good. There we go. Okay. Now why does it not have permission to IO dev USB mon 5? Ah, because it'll have permission to do none of them, that's why. Grup users. Oh, sudo. And then chown, sorry, not chown. Mod group read write. There we go. Bingo. And sweet. That seems to have worked. That was a spicy bug to fix. So, okay, we fixed that. Unused local variable. I don't really care about that right now. We'll come back to it and see. Import and import from standard descriptors. I'm going to plop this all the way down the end so that it's easier for me to nav. So this is complaining that we've got this import and import from construct bytes, construct bytes rather. Let's import bytes then. That allows us to get rid of that. Device model is apparently unused. Yep, that's unused. I guess let's see if that broke anything next. Nope, that looks pretty good actually. Okie dokie. So this one, yes, I'm systematically fixing all of the issues that ViewSB has found in, that LGTM has found in ViewSB, because they almost all point to bugs. So I figured let's clean slate the known bugs that LGTM's found, then go after fun bugs that I found. So that we first create a baseline of good. Hey Freya, welcome, welcome. And then once we've got our baseline of good, we can then improve on that to make it more robust and usable as a debug tool. At least that's the plan. So there's this USB mon backend which has a handle data which looks to be dealing exclusively put my tongue back in my mouth and twist it around a bit, in USB monitor events, whereas this one I'm thinking is going to be a more generic one. Yeah, can handle packet true versus handle data, sorry. Yeah, not implemented error, sub plus must implement. So obviously we are managing to call the correct one. Start a frame filter. Oh, I don't disagree the color scheme isn't good, but I see. It wants us to implement the function to tell it how to call the right one. Correct. The theme by default is bright, and I have dark reader making it dark so my eyes aren't getting burned out my skull by it. Yeah, so the plugin I'm using here is Dark Reader. I can actually make it so, like, for example, it's slightly more contrasty. I personally don't like that though. I have it just default contrast. Or I can make it so it's a little brighter. Again, I don't usually. Yeah. The default theme, if I wasn't using Dark Reader, looks like this. Which, ow, have some very, very bright and dark and eye burny. So, trust me, this is better. Anyway, so I'm thinking, yeah, if we've got USB mon backend, oh, that's the filter. Ah, I need to fix this thing too, but that was not where I was supposed to put that. Backend's USB mon. Yeah, there's absolutely nothing I can do about that. Right, so this is also complaining that we've got the same problem with these can handle packet functions. USB packet filter, which does something a bit more complicated, and then one that just returns true. So if we do can handle packet calls this can handle packet self packet, that fixes one of those two, and then can consume packet is going to be something similar, I'm guessing. Yeah, not implemented error, so we have to call this version. So I fixed some issues with confusable calls to parent class functions. And that's actually that entire class of bugs fixed. Ooh. That's fun. We'll come back to that. Backend, rhododendron, lots of just unused things. So this isn't using argsparse. This is also not using argsparse. Hey Amy, welcome, welcome. Sys is also unused apparently. Okay, fine. The unused, the unknowable great fet imports I can just ignore because they're inconsequential. Unused locals, unused locals. Oh, unused imports. ViewSB commands ViewSB. I haven't actually dived into this part of the code before. Packet ID is indeed completely unused. Don't worry, we will test this again shortly. Make sure I haven't broken anything horribly. Wow, that's actually a lot of unused in this file. It's already quite short. So yeah, that's clearly unused. Clearly unused. That's clearly unused, as is... No, that isn't. Nor's that. there's also groupings. Again, I haven't been into this code. This is just general cleanup at this point. USB status transfer. ViewSB is... Sorry, you missed the start of the stream, didn't you? If I... No, I don't want the LGTM version of things. I want GitHub. ViewSB here is a tool for visualizing and inspecting... no worries. For viewing and inspecting streams of USB traffic and analyzing them and getting an idea of what's what on the wire. So this is a tool that goes well with something like a Luna or OpenVisla, both of which are devices to capture traffic on the wire in a format that can then be analyzed by something like this. Think Wireshark, but specialized for USB. Wireshark, incidentally, is also really, really terrible for doing USB stuff with. Hence the specialized tools. Side 2 import is unused. Yeah, that's correct. Front ends UT. It's not even that it's clunky, it just doesn't do a good job because it's not designed for this kind of traffic. Okay. So 1, 2, 3, 4, and 5 files of cleaned up unused imports. Nice. So that's now all live actually on GitHub. If you were to want to go and pull right now, 17 seconds ago I pushed. Now, that should clean up all of the issues that this has identified. When was this last rebuilt? 12 days ago. When? Gosh, 2 in the morning. So I will rebuild later tonight and hopefully we'll see it go much more green and happy. Let us now have a look at some of the bugs that I've got, that I've found, rather. Let us start with the TUI. So, as we saw earlier, if I use the TUI with my board here, which is SPI Flash Programmer, it just straight up crashes and burns, and I don't know why. So let us... How to investigate. I think I'm going to start by putting some prints in for when we leave certain functions, and maybe also when we enter. I can't GDB with Python, but we can do other inspection methods. We can put breakpoints in and use VS Code to help us a bit. It's complicated though, because the VS Code console doesn't really play nice with Erwid, so I'm going to do print debugging. No, this is there was a crash that happened that was caught but kills the UI. So this is TUI front end dot dunderknit leaving. This is entering. What else can we instrument on this? Handle communications. This is Python, yes. And if it wasn't clear, I have ViewSB installed globally. So if we look at pip list pipe grep programming grep USB, there is ViewSB installed globally, but as a dev thing. Yeah, no, you should be able to read this and cry with me about some of the crimes being committed. Come in. I'm gonna see if we're dying in handle communications here, because that's entirely possible. Hey, JK Ivy, welcome, welcome. Unhandled input. Handle exception. See, we're supposed to get an exception dialog throw up if certain things happen. Let's see what that gives us. That's complicating things nicely. Well, we do our init correctly, so we can get rid of those two. I'm gonna guess that this is the one that was just spamming the console. Okay, that just straight up dies. Wonderful. How to debug this? I guess there's one thing I can do that I haven't yet tried, and that's seeing is it a backend specific error. USB mon TUI. It's kind of. No, that crashed in the same way. So yes, it is something in here. Oh, that's annoying. I guess what I could do then is ViewSB.log. We'll create a file called ViewSB.log, which we have all of this code logged to. Do I want to append? Do I want to write mode this? This is the open built-in. Open the file for writing, appending to the end, if it exists, and binary mode. Yeah. Well, technically I don't need binary mode. Technically we can just open the file. Print calls are all down here now. Where is this called from? Not change, but find. I wanted to find all occurrences. Ah. Analyzer, ViewSB analyzer. Front-end, back-end decoders. Which is a process manager, which is in IPC. Remote class. So it's using subprocess, yes? Well, multiprocessing. Commit the front end, should halt, run. Start, stop. And we can then go looking at the stop call. Remote process join. Heyo, welcome the orb again. And yes, Rachel is correct. I'm having a time trying to figure out how to manage the log file getting closed. I guess I can assume it will just close correctly because we are ending up dying out of Python, so who knows? It's probably fine. So we enter handle incoming packet when we die. Okay. Handle incoming packet makes a call to add packet and then process input. What is root node? Root node is a ViewSB root node. It has a add packet call. Well, it doesn't itself, so I'm guessing this is ViewSB packet node is the one that has the actual add node call, or add packet rather. Yeah, hello. So we can then do a debug print here and a debug print there. Ooh. This is soft.frontends dot. Oh, no, I didn't mean to do that. That's what I was trying to run. I'm actually going to change this from an append to a write. I want to rewrite this log file every time. But we'll do actually complete the add packet. Okay. Also, I'm going to change this. This is going to become that, and that's going to become that, because it'll be more visually distinguishable. ViewSB is it's a separate program from Wireshark. So the README needs work. ViewSB is a tool that, because Wireshark is not good at dealing with USB traffic, and it really could never be because it is designed for network traffic, so the USB support is entirely shoehorned in. It's not very good for debugging things that are going wrong on a USB stream, or trying to inspect what's happening on a USB stream. ViewSB is a tool for using analyzers such as OpenVisla and Luna to look at and debug USB traffic, analyze it, that kind of thing. So it's a purpose-built tool for USB traffic handling and analysis. Okay, so this is ending up calling into the Erwid event handling. What do the key presses End and A do? It's clearly not unhandled input because it's not going into here to deal with that. Luckily, I've been playing with Erwid recently, so I actually kind of know how its event loop works. Ish. For some amount of knowing how it works. So we've got a packet list box. Packet list box. Ah, this is where the end handling is. And we controlled the construction of this completely. So I can temporarily hand self in here. And this is the front end. That allows me to then add in our debug logging here. So we entered key press and we never left. Excellent. So something in here goes very, very, very wrong. Nice. This will be the function that's getting called into from here. Ah, and that does do a refocus. So I wonder then, if I turn auto scroll off, which was me hitting A there. Okay, we still die. But now we're dying in... Oh no, we're still dying in the same spot. 1, 2, 3... 4 packets in. What's the 4th packet that we're ending up with here? It does not like this packet. Oh yeah. Oh my. That indeed doesn't decode in this interface either. So okay, the interface is probably fine. Yeah, there we go. Now we're getting actual error output for it. Let's clean back up. So it's not this part of things that's having the really bad day as such. Although the error reporting needs fixing, because that should have not killed it. Arguably. We have our ways and means. I'm sorry, what? So this is in... Ah, this is in a submodule that we also have to play with. Do I have it open already? This is all construct. So it's when ViewSB descriptor pi line 106 triggers, we try and parse and that goes off into Python USB protocol. Oh, not descriptors, but descriptor.py. And that is line 100. Yeah. Get decoded. Decode data as descriptor. Let's go through get decoded descriptor. Parse with subordinates. Okay, we can fix this by doing a try except return none 0. So now if I run the Qt UI and we look at the qualifier, yeah, this device qualifier, we don't get our unhappy. And if we now do the same thing for TUI, hey, excellent. Okay. Unknown how to render type none type. Cool. How to represent the undecodable data. Parsed equals table or string. Bytes parsed. If table or string do this. Where is parsed used? Is it used in this or not? Oh, okay. If not has attraself.parsed, so we could do if table or string self-parsed table or string, and then if we're not setting parsed, then we know we couldn't decode it as a descriptor. So let's see how that reads. Yeah, okay, so now we just get empty output, which is perfectly good. And same for that. Hey, excellent. And we were able to do that by fixing ViewSB rather than having to fix the other library. Good. I should also pull that other library because it's got a lot of updates that have happened to it. Stage selected changes, and stage selected changes fixed the descriptor decoders crashing when there is an error in a descriptor or the descriptor is unknown to Python USB protocol. Yes, that's a long commit message. I think that's important that it's described like that, though. So, what it was actually trying to do when it died was this is a class method. There's a binary format field that can exist on the type on the class. And these are usually in here in the descriptor stuff. Standard descriptors. No, here we go. Sorry, got the right part. Yeah, come on. There we go. So, for example, configuration descriptors, they have a binary format field, which is from USB protocol types descriptors partial. So if we go looking in the here, this is a standard configuration descriptor. This code base is a little bit of a spaghetti mess, but hey. And here we go. Configuration descriptor is this descriptor format, and here's the actual descriptor. Great, cool. Not everything is properly implemented yet, so let's actually go and see device qualifier descriptor. Let's do a little git blame. Fixed a year ago. Fixed issues with the descriptor length field. Ooh. Expects this to be 9 bytes long. Why? 1, 2, 3, 4, 5, 6, 7, 8, 9 bytes long. Yeah, okay. That makes sense. I wonder if that was just the wrong number before, which was why we were crashing. Do we have... Yeah, there we go. There's device qualifier. having updated, did that fix the decode? No. No, it did not. And also, I'm putting A out. Ooh, I might have a firmware bug that's making ViewSB antsy. So let us look in SpyFlash Programmer at the descriptors subsystem. Trying to scroll along and it don't want to play ball. If we look at device qualifier description 1, 2, 3, 4, 5, 6. Hang on. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ah, and I have the reserved byte in the count. Ooh. I thought that was a part of the count. Oh. Descriptors, there we go. So if we subtract 1 there, and we also mark this as being, is it GNU packed? There we go, this. Let us roll that onto the device and see if USB is any happier. Yep. Okay, that was fun. What I'm wondering is if we try and make this so that it's a little smarter about how it does the decode. Specifically, if it sees I think if it sees a descriptor which has its length byte set wrong, but which is otherwise valid, and is off by 1, would that work? And also, let's quickly go and have a look in the specification and let's see how big that packet is actually supposed to be. We can, yes. So, no worries. You're welcome, HexGen. Get descriptor, get interface. Set address, set configuration, set descriptor. Descriptors, device. Device qualifier. Length is set to it doesn't say. Oh, also interesting. Apparently I'm not supposed to respond with this descriptor anyway. I'm supposed to report an error. Which I can do, but I do want to fix this. Whatever. If I'm supposed to report an error, let's do that. So this is not unhandled, but stall. And 0. There we go. So now if we run that, what does ViewSB say? Stall, stall, stall. And then it moves on. So, okay, that works. And it doesn't make my kernel unhappy. That's nice. Okay. Let us put this fix in repo. Oh, I've got to come back to that. Oh, I already did. Right, I was going to look at trying to do some further decoding on packet data. Requests. Decoded packet. That should be that. Oh, this was for summarized data. So this is me, I think, looking at how to make the... Yeah, I think I know what I was doing here. We've got to revise all this and figure out how it should really work, because spicy. Okay. Let's commit a fix here, so I can then start messing with versions of this firmware, and I'm going to try and see if I can break ViewSB in other fun and interesting ways, which we should be able to. And if we can try and improve the output when we do break it. Let's see. That can get put into a stash. That can get put into a stash? No. Temporarily disabled part of handle read in the firmware. Improvements to the debug info handling in the linker script. That can get put in a stash. What does it think it can do for me for .sch files? Huh, it thinks there might be scheme. Nope. KiCad can be a little with regards to how it updates files. So yeah, this looks like I can just add everything there as various KiCad meta fixes. That can get stashed, and that can get stashed. Okay. We are now on a clean version of SPI Flash Programmer. I'm gonna do a skip on that because that's, yeah, demo stuff only, not the real thing. So, oh, actually not this window because I don't really want to mess with the build window. This one. Here's one I prepared earlier. Good. So, early versions of the firmware that broke all kinds of rules. Let's have a look. In actual fact, I'm going to use git blame here to see when did I edit certain things. Like, here we go. I want to see when that commit was made. Switch to commit. Let's see if this builds. Ah, so that's how that looks. Looks like we might be partway through a commit series. That's fun. Switch to commit. That's still angry. Spicy. Those are things that are almost entirely errors in device CXX here. Handle, USB packet, etc. Yeah, those are supposed to have that on the front of them. And that is also, well, that feels like there's a missing using. "313. What's the error there? Expected a declaration. Namespace. Function, 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 function. Also, yeah, this is in the USB device namespace. What the hell is this making me put that in for? That feels like I've got an error further up in the file. That is being masked. Namespace, USB device. Namespace, USB device. Ah, that's the error right there. Double squirrely brace close. So this now considers this to be in the namespace, this to be in the namespace. Okay. Ah. Oh, this was before I had the program target. Oh, spicy. Okay. So I want to no, target extended remote dev TTY Blackmagic probe GDB patch on load and exit out. I think that's right. No, it was kill and then haha. Thank you. Yes, I can actually show you that if you'd like. It's not that complicated to set up, but it's fun to, and it actually is very, very helpful for seeing where you are in a complicated debug situation. I have apparently forgotten how my program target works, which means it works a little too well. Let's pull that apart. There we go. Now it did the right thing. Let's see how badly ViewSB choked on that. It did so less badly than I thought it would. That used to just straight up kill it. Interesting. Yeah, okay, so we've now got these descriptors that don't decode properly. Which is nice and fun. So it looks like I might have to ask it. It looks like I reverted slightly too far back in that I'm not getting some of the attempts to transfer descriptors I need in order to break things. Though, theoretically it should. Yeah, theoretically that should be very, very broken right now. This is E1, EB1, DC4A. I'm going to put us back on master or main, and I'm going to discard those changes in order to do so. There we go. And I'm actually just going to manage to just remove these pacts manually and see what breaks. Is that the only thing that was packed? Apparently. Maybe. I'm going to temporarily have to disable a static assertion there, because that will break. Hilariously enough. Let us apply the stash, well, populate the stash. Yeah, so that gets us all of those fixes that I've got on main. And let's see what happens. So that builds. Oh, interesting. Oh, I haven't got the target powered, that's why. Go me. Good. And we're back to mostly working. And yeah, okay, so these don't decode correctly at the moment. That's fun. How do I want to get this to handle this? So the error path that we're triggering is no, I'm in the wrong file again. It's this one here that we've literally just added today. We add a print in here that failed to decode the script or data have len data bytes expected descriptor length and if we use the Qt UI so that we get to see the output on the console without it messing up the UI, have 33 bytes expected 10, have 9 expected 9. Interesting. Ah. Oh, right, because that's... So if the amount of descriptor data is less than the value we pulled... Okay, if we don't... Ooh. Yeah, this is where... What exactly is the error we get out from this? So this was throwing a const error. Have I got an easy way to get a nice way to represent that? Probably not. Ooh. Unbound local error. Oh. Ah, because I forgot to put a return in. So the error that we get is parsing expected 9 but parsed 10. Parsed data to detailed dictionary. So those are some special things on descriptor format. Okay, that's from... up one. Is that descriptor format? From dot descriptor format. Yeah, okay. Spaghetti code, everyone. Spaghetti code. Here it is, descriptor format, and this has to detailed dictionary. Yes. Which is quite literally going to create a dictionary from whatever. Detail key. I'm betting then that that is where we get these names and then what the values are from. So if we pop out decoding error as the key and error dot well wrapper of error as our result. Does that work? Is that going to cause us problems? That does cause us problems. Ooh. So if I return null, but I actually do set self-parsed as a result, that will fix that one. Let's see what that does. Self is not defined? Oh, is this a class? This is a class method. Is there a reason why this is being done as a class method? Oh, it's so it can get at this data cleanly. I could do the error handling out here. I'm not gonna get such nice errors, but I could do it out there. So what do we now get? We now get... Haha. Configuration, decoding error, and then whoops, because I didn't yet quite represent that nicely. And no error output. Mind you, no output, but that's, I think, correct now. Yeah, so if we do that, that'll land us here. General exceptions, just do that. Error in path. Path is none. Call exceptions base. I really want to just get at the parsing expected 9 but parsed 10 message. I don't really want the error in path prefix. What have I got available to me? I can get at the path part. Mm-hmm. Okay, that's better. Error in that. If I do this as a split on new line, I'm gonna have to do some string manipulation to make this work, aren't I? Hey, okay. I'm going to make this so that this part to the right of the arrow is the configuration key. Because it tells you then exactly what you got wrong in your descriptor, which is nice. If it is, of course, not none, in which case, what's the name of the function that cleans up? Not trim. Oh, I keep forgetting this. Strip, there we go. Let's see what that does. V length, passing expected 9, but passed 10. Hey, there we go. I think I'm going to move that down. Just catch everything like that so that we can then more cleanly extend this later if we have to deal with other kinds of errors and how to reparse them for display. Let's also test that that worked with the TUI next. Oops. Parsing expected 9 but parsed 10. There we go. The UI works very nicely there. Language entries, that. Are those the only errors? Looks like. So if we undo the intentional messing up the code to make it intentionally break, where are we at? Perfect. I'm surprised those additional types didn't need their padding fixing either. Interesting. But this does look very, very good, actually. This is exactly how I'd hope it would look. So, the thing I was looking at here, the thing I keep kind of half going back to and then ignoring, this is to do with trying to make it so that the output is a little more readable up front. So if we re-enable this, and we run the TUI, if I recall correctly, this is now going to try and do some more... Oh, well that makes it crash, apparently. That was supposed to make the output here, I think it was, more usable. Because it just says 18-byte in transfer and then doesn't decode anything at this layer. And we also don't decode anything here, which is unfortunate because trying to decode setup packets is actually a bit of a pain. So, oh, and I was going to show HexChen GDB prompt stuff real quick, which is something I can easily do. So this is how I do my GDB prompt. It uses this extended prompt thing, which Aki let me know about. This is how I'm able to then put color in. Unfortunately, it doesn't support getting what host you're currently on, but then it does say you can get where the working directory is, and then I put in the thread and the frame, which I'm currently debugging before I then put out the angle bracket to say enter prompt, here you go, away you go. That's how I get my really nice prompts. And you can kind of see as well from this why I think this is more helpful, because if you're very highly multi-threaded programming, the thread that crashed and the frame you're currently looking at, it can be quite difficult to keep that information in your head. So having it displayed on the console at all times is quite handy. Let's see. So Where is... We are summarizing a control request setup transfer for in. That's this summarized line here. That's what puts out this data here. That's the bit there where you want it decoded. So what does the USB standard say is in a setup packet and how to decode this? We have VM request type, which is a descriptor field descriptor format. Where is that actually defined and how to import it? Oh, that was right. That's in Python USB protocol. Deep in its guts. Descriptor format, descriptor field. We then have... keep doing the wrong thing. There we go. Request. Specific request. See table that. What is a descriptor number? Descriptor number is a special thing for a special kind of constant. Ah, okay. Descriptor field is a really special type that actually has knowledge of how USB things are described. Excellent. So this will automatically do the right thing. That looks like that's everything. Let's make this formatted the same as other things here. There we go. Should have given us get descriptor. This is very intriguing code in that I'm not quite sure where this is even called from. Have I got an easy way to get Python to tell me where something is being called from? I could do a Python throw catch that would work, but I don't really want to do that. Python 3 get call get stack trace without exception. Traceback print stack. I think you just call that, actually. Let's do that, and let's do the same thing here in this. I need now, wow, words. I can't words. Now I have to use the Qt GUI in order to be able to not clobber the output. Those are never getting called. Interesting. I wonder if this one though does, because this is how to crash ViewSB. Okay, that did cause some issues, but good. Summarize data gets called from front ends. Front ends Qt line 416. I'm gonna do a whole thing here where I do a get call to do unknown, and let's use f strings, because why am I not using f strings, for crying out loud? I can put in that entire thing in an f string. That's easier to read. Boy, if only I thought of putting an f string in there first. Yeah. And at the moment that's complaining because it can't find this attribute. Which it now should be able to, because I've just given it the attribute. Lots of print stack. Interesting. Oh, take care. Thanks for watching, HexGen. And get detail fields, packet line 269. Where is that? Two six nine. Get field details. USB packet. So what this is currently making it look like is this, which is not great, but it works, I guess. What I actually want to do is get it to look like that. So I think what I'm going to do is I'm going to look at a standard descriptor. How is this being, well, actually, sorry. A descriptor transfer. How is this being parsed? So I've got get decoded descriptor, parse with subordinates, get detail fields. Okay, so this is the actual function I want to override to make this pretty. Because that allows us to display the raw data here and then the decoded data here. I think. Yeah, this is a transaction too. That's already open over the other side. Let's pop that over here so I've got it for reference. This doesn't have any of the summarize stuff. Okay, that's intriguing. I wonder what the thinking there was. So pass with subordinates. Get raw data. If not data, return none. This is just some insurance policy to make sure that we don't crash horribly. And get decoded descriptor. Code data as descriptor. This is the bit that does the actual work. We do need to do this whole if not pretty names thing, probably. But oh, hang on, no. This is always with pretty, so yeah. Data gets passed in, pretty names defaults to true. So this is always false as far as we're concerned. We can do a translation. If has ACTRA parsed data, B request parsed data B request is that. Yeah. Why am I don't need a format call. I can just get the thing because it's already a string here. To detail dictionary. which out here comes self-parsed. Oh, that's for caching. If not has Atra self-parsed, then we run this to get that. We need a, we'll call it name, setup, there. Which we then have to do this whole table list is name parsed and we need to do that. I am in C++ mode apparently. Nice. Plus the setup data according to binary format. I'm actually just going to do self.binary format there because I can. And likewise self.requests. Translate the setup request name. So, what has that managed to do? Has it managed to work? That's the question I've got. Let's get rid of some of these because they are not helping us. They're just making life fun. So this is actually doing the same thing as part of what we've got down here. But I think this is a horrible, horrible mistake. I think if I recall correctly, setup tokens never have a length embedded in them. They only have the data, because they're always assumed to be 8 bytes long, which is an interesting attack vector to possibly poke at some point. Okay, we got some exceptions throwing that. Oh, fun. Summarized data still has a print stack in it. Whoopsie. Let's redo that, because what I got out was kind of unreadable. Okay, so packet line 815. Self-subordinates. This is the mistake of just copying code verbatim. Not all of it is suitable. Ah. There are no subordinates, so I don't need to do that. That would be an empty list, so save ourselves the time. Hurrah! Cleanup is done. I fixed some very fun, spicy crashes. And we're currently making it so that setup transfers decode because, geez. um, I can do better. We will do better than just displaying the raw bytes. It explodes nests now. Yeah, we're on to the improving it part now. Which has been driving me slightly bonkers because the code is not terribly easy to get your head around. I'm gonna get rid of this. That's now not required. I think Repper is entirely new. I'm not sure if I need that. And it's never getting called. I'm inclined for the moment to spicy comment out Repper. Um, I need to come back to this because it would be helpful to kind of maybe make use of this, but I'm going to comment that out as well. Let's see what that does. I also now want to go and based on... I need to do some extra decode there. I need to decode the request type data and the request data some more. And then I can then do some extra interpretation on this data and make it nicer. That's, I think, how I'm going to deal with this. So I think I now understand how this is structured. So as long as I keep having arrays inside parsed, it'll create a nested structure that it'll display quite nicely with key value pairs, essentially. Or rather, sorry, dictionaries, not yeah, it's dictionaries. Dictionaries and dictionaries. Spicy. So we need that little lot. Oh, yeah, this is the wrong view. This view. Stage that. Stage that. and stage that. I don't need that anymore. Let's see what this looks like on the 2E. Yeah, that's nice. I don't think I want them capitalized. Have I got an easy way to lowercase these? Not really. Also, everything seemed to work correctly, so I'm going to delete this wrapper code. Past data, we have this field, which we should always have, but if it's errored in any way, we'll know from this. Well, oh, this... Okay, this is going to explode if the setup token is invalid. However, the only way that can happen is if the host stack is talking gibberish. But who's to say that you're not trying to debug a host stack, right? Because you could be using the analyzer to see how the hell a host is blowing things up rather than a device. So, where's the... Oh, there it is. We'll do the same thing as we did here, but to this entire thing. So if we try catch, well, not catch, sorry, accept const error as error, and we grab that, instead of having to do the whole self-parsed thing, we'll do that. So it's an early return that makes a neat little error display for what went wrong. That is this import, which we'll need. So password subordinates does a get decoded descriptor. Get decoded descriptor does this. Here. So this is the thing that we need to then deal with. If we get here, we can assume. It's impossible for that to const error, isn't it? Because I haven't put any const stuff in here. Okay, so what I can actually do instead is if I do if len data not equals to 8, then return self name invalid setup packet length. And we don't need that. We don't need to add this. So that guarantees that we'll have the fields. Before we do a translation of that, we want to do self to decode request. I'm just going to call that translate the setup request. Actually, let's call this a class method, because then I can get at the class data a little easier. So that is parsed data. The request is CLS requests get, and then instead of dealing with the fields there, I can just deal directly in, for example, B request. This. Let's make my life easier by shortening things. I'm also inclined at this point to go and open, say, Spy-Flash Programmer. It's descriptor handling, because it actually describes how to deal with setup packets fairly completely. I mean, it has to be able to work. Not common firmware. Firmware is what I'm looking for. So it's got device and descriptors. Handle get descriptor. So this is an interpretation of the value element. So I'll do another class method. If data bm oh, this is the value part. W value. So this is two values. It's big endian. I wonder how Kate is dealing with. I wonder how Kate is dealing with int16 UL here. Field type, length, field prefix. That's deep in the heart of construct. I wonder if the L there is for little endian. And I'm now kicking myself for closing the browser window. Construct. There are exactly two references to it. Neither of them are links. I don't want a tutorial, I want a reference. Hey! Integers and floats, maybe? So I can now put this back over here because we're actually done with it. Unsigned little endian 16-bit integer. Okay, yeah, so it does stand for little endian. That has some profound implications. So to get at this first number, I need to... Hey, my Aegis, welcome, welcome. Little endian means that the least significant byte comes first, rather than the most. So we need that for index, and type is data w value 8. If type is, let's call that desk type so we're not munging Python built-ins. Do we have a listing of all of the script types? No. Data w value is the dictionary of index and type unknown. Data w value type is device. Take care, Lillian, sleep well. I'm guessing this is 2? No, 6. So 1, 6, 2. I'll go through the rest of those in a moment. What I do want to do though is find where that is called in here. Handle standard request, dispatches on packet request, which is, yeah, the second field. That's what I figured. So this is get descriptor. Which is 6. Okay, let's see if that worked. Before I go further, let's just see if that worked. If it did, this one here should show device descriptor as its name, and it should decode index more nicely. Kind of. Value index 0 type device. I mean, that's nearly what I was after. This makes me wonder, how is this working with regards then to subordinates? Oh, that just appends into the list. think it has support for what I want to do. Well, it's certainly got support for that. Welcome back, my Aegis. Fair comment. We are in having fun in the depths of ViewSB, trying to make it so that setup packets decode and you can then understand your traffic better. So we've already got it so that now here, instead of just displaying the raw bytes, that we already know what the raw bytes are, we know that this is a setup transfer and what the basics mean, which is nice, but let's have it better, right? So like if I want to, I can go and see, yep, that's set address, and it doesn't explode, and its value is 3, and which is kind of great. But I'd like to make this so that this decodes to better, because we can. We know how to. We have the standard. So I'm currently fighting ViewSB a little bit. This is the field that we're decoding. We're giving it a dictionary, but it's not displaying the dictionary properly. Earlier it was exploding USB analyzers, which is not fun. Or rather, visualizers. Populate hex view. Populate decoder view. I wasn't trying to. Render each table in the detail fields. Get detail fields. Yep, this is in Python. ViewSB is written in Python. You can thank Kate and Curiad for that. It wants to see a contents is collections mapping. At which point it will do the almost right thing. This has been written in quite a specific way. So this knows that we've got a mapping coming in. Decoder rows append text this. This is, by the way, this is how Erwid knows to mark that as red on my console. I didn't write ViewSB. Kate and Curiad did. Mostly Kate. Which is this wonderful thing. It's actually got 3 different UI modes. We're currently looking at the 2E. Text UI. Text UI is written using Erwid. And we're improving it because it was crashy and didn't give us some very helpful information, as you might recall from earlier streams I've done trying to write USB driver stuff, where I'm like, okay, so what's this setup packet? Now let's go and view the standard and find the right part of the standard, and tearing apart USB stuff by hand when this could have for me. So we're at the point where we're yeah, we're at the point where we're actually able to pull apart setup packet automatically, kind of. But I'm trying to make this so that instead of displaying a dictionary over here, which, I mean, that kind of works, I was hoping to create a thing where we'd see, like, under value, index and type, and then the values for those things. That's what I'd like to do. I think I can make it happen by messing about in this thing, which instead of just doing a columns equals and appending a new columns item, I think if I grab that, if is instance value dict do thing else do those things, we can then make this work. So if I do self decoder rows append that. So Erwid has some interesting stuff happening here, which I can explain. So this, and some other things like that, wherever you see a word before some text going into erwid.text, these are attributes, and you can then apply what's known as an attribute mapper to then map those to colors on a console. Be it your straight 16 color console stuff, or if you want to, you can go and put out 256 color console codes, or you can put RGB out with some extra work. It's quite expensive actually how it can do it. Which allows you to do relatively easy stylability of the UI, so you can remap the colors and offer a interface inside your TUI to be able to do that, which is honestly really nice. So this is padding 1. For how do I want to do this? I'm gonna make this a recursive thing. So if we do padding 1 here, yes, please do go sort yourself tea, supper, whichever you prefer. So if we then do self add key value table to decoder view table padding equals padding plus 1. Does that do what I'm after? Probably. Does it explode? Who knows? Yes, it explodes. Okay. So Hmm. I think that might have been Erwid dying because I told it to do something bad. Oh, no. That just crashes. Interesting. Let's add a try catch. And the catch is going, well, oh, Python, help dict. Set like an object providing view on these items. I mean, that's correct, yes. It wasn't inspect. Is that the deprecated one? Sys exec info. Okay. Anyway. Fail to add filled items to display table, and we'll put this out onto sys error, stud error rather, because I don't think it messes with stud error. I think it only messes with stud out. Okay, no, it messes with both. Fine. With open ViewSB.log write as file. How to get debug info out of your TUI. Huh, don't. What is this wanting to actually do here? Exception up to limit stack trace entries from TB to file. In theory, this is doing the exact same thing. But there we go. I don't know why that didn't work the first time round, but whatever. Maximum recursion depth exceeded. Ooh. Oh. Yes, it would. Indeed. Okay, that didn't crash, but it's also not quite done what we wanted. It kind of worked. One of, maybe. So what I now... Oh, right, that's why it didn't. I need to hand into... here. Padding equals. And then that'll do the right thing. And I don't need that anymore because we're no longer crashing. Because I'm not doing stupid things. Hey, would you look at that? That's exactly what we were wanting. Okay, now I can continue trying to write up all of the different descriptor types. Which, there we go. Yes, probably is a little low. We'll come back and fix that in a moment. I want to first make this work. This is where I kind of want a function just to do if thing return value and then have one assignment, or actually directly plonk it in there. how to make this work. That can all go. So this is decode descriptor type sorry, desk type even. That feels much better. There we go. 3, 4, 5. Interface endpoint. Oh. String. Looks like 15 is skipped. So I then get 16. Device capability. Wireless endpoint. What is that in not hex? $33, $34, and $35. Okay. Okay, that's all of those translated. Addressing is a bit weird. Because the value that it's keeping is the what's the direction bit is set to 0 to indicate Oh, so this is all again. Indexes interpretation is dependent on the request field. Data.vm request type equals split. So this is actually, I shift this down 7 bits. I don't need to do the ampersand one then. That's the direction. Type is data VM request type shifted down 5 bits and is 2 bits. This is the low 5 bits. So we have more static methods. So we've got 3 request types that we actually decode. If rec type is 0, then the response is standard. Lf request type is 1. Then it's class. If it's 2, then it's vendor. Otherwise, it is reserved. If the recipient field is 0, it is for device, else if it's 1, then it is for interface, it's 2, it's for the endpoint. If it's 3, it's for other, otherwise it's reserved. let's see how that's looking. Oh, that's amazing. Yeah, that's the exact kind of decode I wanted. So we've now got request type is direction device to host, type standard, recipient device, etc. And just boom, done. You don't have to go looking at the standard, you can just get it from here. I will now increase the padding because I agree that is a little unreadable. Luckily, it's just one number. And that's fixed it in all GUIs. I'm also inclined actually to make that not just one space indent initially, but two. It's not unreadable that way though, but index. Let's go and have a look at how to decode index now, because we've got most of the things we need to decode decoding, which is great. So index is zero or language ID. Oh, I know exactly what that is then. Data dot oof. Thank you. Sleep well, my Aegis. I'm probably going to wrap up shortly because we've got what I wanted to get working. It's just putting some finishing touches on now. Yeah, W index for some godforsaken reason is taken to be a language ID here. If data W index not equals 0, language self decode descriptor lang. I'm going to actually format that to be consistent with everything else. I don't need to, but now the special thing that languages have is this 0904 return English return the F string unknown lang formatted as a OX prefixed 4-byte number, which the 6 there is, I want 4 bytes of hex always, but the 0x on the front makes it 6 bytes for the yeah, formatting string with weirdness. It's fun. So where does that get us? Crash. Yep, bad alloc, heavy industries. It's bad underscore alloc, by the way. Blame Aki? No, I wouldn't blame her. It's a name that she came up with originally, and then I ended up becoming a part of, which is where all of our common projects are. So, for example, Substrate is there, which is our everything that we wish was in the standard library that isn't, along with compatibility shims for stuff that we wish was in older standards that isn't when we're trying to use those older standards. Oh, that's why it crashed. Yep, thought so. So the number that we were seeing there is the language value English. Of course. So, yeah, that's now decoding very, very nicely. Let us add that to the repo. Am I using sys anywhere? No. Oh, excellent. I'm glad to hear you're repairing it rather than throwing it away. Too many people would just throw it away, go, it's broken! But Mac keyboards are expensive enough that that's worth doing. So the change set I've just created, it greatly improve decoding and display of Yep. Luckily, keycaps are not too expensive to get your hands on replacements and new ones. They all have a set standard that they have to fit for basically MX, Cherry MX key type keys and standard set of dimensions. I say standard, it's de facto standard. Great improved decoding and display. Well, I mean, Razer tends to use MX compatible keys, I think. So if you wanted to, you could go on to basically any mechanical key outlet, or other mechanical keyboard outlet that has MX keycaps, and you'll get something that fits. It might not fit in with the rest of the keycaps, that's where you have to be a bit more picky, but it would fit the keys. Greatly improved decoding and display of setup packets. And let's actually just see what this looks like in GUI mode, as in Qt GUI. Okay, I have to fix the Qt GUI. Well, we know that's possible. I wonder where that is happening. Softly walk packet. Great item for packet. Update detail fields. Queue widget item. Ah, excellent. What we'll do here, if instance dict, self dot dict to items yeah. Oh, it was right. Extend that. If is instance value dict, else return children. item is QTree widget item key item add children self dict to items of value. Which is the recursive case. Yeah, that looks about right. GUIs are headache inducing. So now if I click here, press get descriptor. Ooh, interesting. That didn't like that. It's not throwing exceptions, but it didn't do the right thing. Oh. Because I didn't append the item to the array. Oops. Voila! Oh, that looks so good. That is just, very nice. The only other mode I haven't tried yet, all evening, is actually the CLI mode, which we should do. We'll see what comes out. Huh. I think I'm okay with this. This doesn't read too badly. Which for a command line interface only thing is, you know, good, actually. Set up transfer token packet, data packet. And if you care to decode it, yeah, if you care to decode it, you can. The data's there. That's the most important part. And then it's doing the decode as much as it can of stuff. I don't hate it. Work with there we go. Wow. I wasn't quite expecting to manage to make that work for what it's worth. Thank you all for bearing with me in what has got to have been at points very dry content. Some very fun output there. My IDE getting a bit confused probably. Yeah, I am happy though that now ViewSB has A, considerably better robustness. Oh, fair enough. And B, it's got a much better setup packet decoder, which is good because that was one of the most frustrating things about using it before. There is one more thing I want to do before I completely wrap up stream. Noting that the next stream I do, I think I want to work on keyboard again. Yeah, keyboard again. Before I do that though, I think I know of a bug in this little lot, SPI Flash Programmer, which we're going to quickly have a look at and use this as a way to prove what we've just done works and is good. The thing that I'm looking at is that handle read here. I think it's not quite working how it's supposed to. I think it's doing some insane things. So if we do 2E interface, and build software flash prog, read ship 0 flash bin. This is probably making my machine mad at me right now. If I unplug, gives me a nice error, which error outputs display nicely. Excellent. We didn't get a damn decode. That's very annoying. Have I just accidentally queued out as it's about to give me a decode? Probably. Yep. Let's try the QTUI instead then. So, yeah, this is what I thought. We've got... See if I can get some reference up side by side a bit. We have... oh, this isn't descriptors. No, I'm not looking at descriptors right now. It's this file. Here we go. So device count 0 would be byte 0, a byte of 0 here. Byte 1 is device list device. So this was me asking the device, could you tell me what you support? I then tell it, okay, please select a specific device. That's the response from this, which is out of order because Vizsla's kind of grisly to work with. This is the response from this to say all okay. We then have a 4-byte packet, which is a read packet. This is read and then page 0. We then get... Ooh, that's interesting. 1, 2, 3 bytes more than, yeah. So this part is the actual data that we intended to send. We then have an extra byte which is not what we intended to send. So write EP busy. I'll write EP busy. I have a funny feeling we are not running part of the state machine that we need to run in order to clean out device state. Because this thing has a state machine inside of it, which is kind of annoying to work with. So what I'm looking at here, to explain myself a bit, we ask for 64 bytes, which should be a packet full of Fs. We then ask for it again, and then we ask for one last time before we then issue the 1 byte in transfer, which should have had this 4. So it's almost like what we're doing is we're managing to overwrite the FIFO. That's actually what this looks like. This looks like we're managing to overwrite the FIFO repeatedly, which is very, very bad. So we should be going while write EP busy, endpoint 1, just loop. This should be in USB core, write EP busy. Which is while this transfer bit is high. Now, USB controller, where are you? I am blind? No, there it is. Doop-a-doop. Yeah, see, this thing doesn't actually document its state machine except in text, which is thoroughly annoying. Operationist device, endpoints, in transactions as a device. Data for in transactions is handled through FIFOs attached to the transmit endpoints. So we're doing double packet buffering, or we should be at least. If the size of the transmit endpoint's FIFO is at least twice the maximum packet size for this endpoint. Am I setting USB TX max P1? I don't know. That should be a part of set configuration. Yeah, I am actually setting that correctly. And then size we map to be twice the packet size. So yeah, this should be hitting the double buffering. As each packet is loaded into the transmit FIFO, the TX RDY bit in this register should be set, well, must be set. We're not doing auto set. When the TX RDY bit is set, either manually or automatically, packet is ready to be sent. After the first packet is loaded, TXRDY is immediately cleared and an interrupt is generated. I should probably deal with that interrupt, actually. Yeah. That's going to be a fun thing to have to do here. That shouldn't be... Oh! Right, yeah, USB CTRL because of the namespace problem. EP controls 0 because we're on the first endpoint. No, none of those. RX interrupt status. That's going to be what I have to go and pop bits in. So, I think at least. No, oh, that's right. It's transmit interrupt status, and we're gonna have to clear a bit in there. So the way this works, after an interrupt has been generated, a second packet can now be loaded into the transmit FIFO and TXRDY set again. Actually, I know what I'm going to do at the start of this little lot. I'm going to turn off the interrupt for endpoint 1 and turn it back on again at the end. So therefore we won't have to deal with spurious extra interrupts. They're just going to get silently dropped for us. Thanks to ARM for having a sane way to do interrupts. After each packet has been successfully sent, TXRDY is automatically cleared. Yeah, so we should be fine. This is checking endpoint 1 is controls 0. TX status control low. That's this thing. Is this bit set? And if it is, then we're busy. Otherwise, we're good to go. I think that's how this works. For now, I'm going to see if this improves if we go and stick this into single buffering mode. Oh, I forgot to power the board back up. I'm like, why didn't it program? Why am I seeing nothing? Oh, I forgot to power it back up. Very me problem. Ooh. Spicy. Oh, okay, I see. Oopsie. Yeah, that hasn't fixed a darn thing. So yeah, this is to do with how we're writing data out. Fun times. Anyway, this has proved his point, which is that now it's usable to be able to kind of figure out what's going on in a transaction, and it doesn't crash when you give it weird data. So with that, thank you all for watching. I hope you've enjoyed this stream. As I say, next week I plan to do a stream again on the keyboard, as I've got some interesting stuff I've been doing with the PDI protocol stuff, so debug and programming protocol, programming debug interface protocol, that's what it stands for. I've also got the next step of trying to get it to actually being a keyboard to do, which is where we're going to write firmware to translate key presses on the board into scan codes, and then from scan codes into actual communications, and we'll start trying to make it do things like spew scan codes at Vizsla, sorry, not Vizsla, Glasgow, and also see if we can get it talking USB HID, which admittedly could be quite a large chunk of work to bite off in one stream. We'll see how it goes. So with that, thank you all for watching, and I will see you next stream. I noticed that Shannon 50k is currently streaming, so we are going to raid him. You're very welcome, Keithy. Take care, Obliterus. Yep. Enjoy. I have to go and put that through Translate.